So this is your chapter 5, the 5.1 through 5.6 test review. Your test tomorrow, 8 questions. Everything you see on your review, you're going to see on your test. Okay? So if we look at the first thing that you see here, you're working with law of sines. So you have the possibility with your law of sines to have 1 triangle, 2 triangles, or no triangle. What you're first going to do, you're going to find the missing angle or missing side length that you have given what you are working with. So like for your first example, you have that A is equal to 9, B is equal to 7, and angle A is 108 degrees. So because you have both the side length A and the angle A, you can use sine A over A is equal to sine B over B. Plug your values in and simplify. So this is going to give you the sine of 108 over 9 is equal to sine big B over 7. Cross multiply. This gives you 9 times sine B is equal to 7 sine 108. You can divide each side by the 9, and you get that angle B is going to equal sine negative to the power of -1, so the inverse sine of 7 sine 108 over 9. We use our calculator. The inverse sine of 7 sine 108 over 9. This is a 9. Is approximately 48 degrees. So to find if you have a triangle 2, you can take that 48 and subtract it from 180. So if we do this is triangle 1. If we have a triangle 2, we can do 180 minus 48. This gives us 132. So if we take the 132 and we add it with the 108 that's first given to us, that gives us 240 degrees. A triangle is how many degrees? 180. So that 240 is bigger than 180, so there's no possibility that you're going to have a triangle 2. So work with just what you have with that angle B. You already have that angle A is 108. You have angle B is now 48 degrees. So find angle C. To find angle C, we can do 180 minus the sum of the 2 angles that we have, which is 108 and 48 degrees. So 180 minus 108 minus 48 gives us 24 degrees. So angle C is 24 degrees. So far, we have that angle B is 48 degrees and angle C is 24 degrees. We still need to find side C. So use your law of sines. Do sine A over A is equal to sine C over C. This is going to give us sine 108 over 9 is equal to sine, 24 over C. Cross multiply. So this gives us C times sine 108 over 9 is equal to, sorry, not over 9. C sine 108 is equal to 9 sine 24. So from here, just divide each side with the sine 108. And this gives you 9 sine 24 over sine 108 is going to be 3.849. We're rounding side lengths to the nearest tenth, so that's 3.9, or sorry, 3.8. To number 5. So this one you can actually see. All right. For this one, it gives you that angle C is 26 degrees, side C is 5, and side B is 9. So because angle C and side C are both given to you, you want to start with that. So we're going to use sine C over C is equal to, you're finding angle B because you have side B. So that's going to be sine B over B. So because, like I said, we are given side C with angle C, when you go to find any other side length or angle measurement, you want to use that sine C over C and the other one, which could be sine A over A. So with this, plug in your values and solve for at least the angle B. This is going to give you sine 26 over 5 is equal to sine big B over 9. We're going to cross multiply. This gives us 5 times sine B is equal to 9 sine 26. Divide each side by the 5. This gives us that angle B is going to be found by taking the inverse sine of 9 sine 26 over 5. So we use our calculator. The inverse sine of 9 sine 26 over 5 gives us angle B is equal to 52 degrees. So this 52 degrees is rounded. So again, it's not precise. So if we're going to find another angle measurement or another side length when we find side A, we're going to use sine C over C is equal to sine A over A. So this would be for triangle 1 if we have more than one triangle. If we have 2 triangles, we can take that 52 degrees, subtract it from 180. This gives us 128. So if we treat this like angle B, and we already have that angle C is 26 degrees, if we add these up and then subtract that from 180, we get 154. That's less than 180. So to get angle A for your triangle 2, you're going to take 180 minus 154. And that gives you 26 degrees. So your angle A for this one would be 26 degrees. Your angle B is the 128. And again, your angle C is already given to you with the 26 degrees. So from here, we still have to find angle A for that first triangle. So for the first triangle, we're just going to do 180 minus the sum of the 2 angles that we have. So the 26 degrees and the 52 degrees. So that gives us that angle A would be 102 degrees. So for both of these now, the only thing missing is side A. So to find side A for both, we can use sine C over C is equal to sine A over A. So we're going to plug these values in. I'm going to work with triangle 1 first, then I'll go ahead and work with triangle 2. For sine C over C, that's going to give us sine 26 over 5. For sine A over A, that's going to be sine 102 over A. I'm going to cross multiply with these, and that's going to give us A times sine 26 is equal to 5 sine 102. We're going to divide each side by the sine 26. So when you divide these, you get that angle, or sorry, the side A rounded to the nearest tenth is 11.2. So for triangle 1, you have angle A is 102 degrees. Angle B is, where did it go? Angle B is 52 degrees. And angle C was given to us of 26 degrees. Side A, we found, is 11.2. Side B was given to us at 9. And side C was given to us at 5. So all of this is for triangle 1. You still have to find side A for triangle 2 now. So we'll go back to triangle 2 and solve for that. So if we plug in our values for sine C over C is equal to sine A over A, that's going to give us sine 26 over 5 is equal to sine 26 over A. So from here, we're going to cross multiply. And this is going to give us A times sine 26 is equal to 5 sine 26. We divide each side by the sine 26. These cancel. They also cancel out on the other side, so you don't even need your calculator. You just have that A is equal to 5. So for this one, for triangle 2, you have that angle A is 26 degrees. Angle B is 128 degrees. Angle C was given to us at 26 degrees. Side A is 5. Side B is 9. That was given to us. And side C is 5. Again, that one was given to us also. So this is one of those instances where you have two triangles. You need to make sure that you find all of the side lengths and all of the angle measurements for both triangles. When you do law of cosines, you want to find the biggest side length or the biggest angle first, and then move to your second biggest, then your last. If we look at number 8, you have that angle A is 42 degrees, angle B is 12, or sorry, side B is 12, and side C is 19. So this one, because we have angle A, we're going to use A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. We plug in our values. So you could also tell me that A is equal to the square root of all of the stuff to the left, or sorry, to the right of that equal sign. So that's going to be the square root of 12 squared plus 19 squared minus 2 times 12 times 19 times the cosine of 42. So this one, real simple, just plug all of this into your calculator and simplify. So if we do that, the square root of 12 squared plus 19 squared minus 2 times 12 times 19 times the cosine of 42 is going to give us 12.88. So if we round to the nearest tenth, which is telling us your side A is equal to 12.9. We still have to find angle B and angle C. So now that you found side A, you can use your law of sines. So you can use sine A over A is equal to, C is your second biggest side length there, so use sine C over C. This is going to give us sine 42 over 12.9 is equal to sine C over 19. Cross multiply. This leaves you with 12.9 sine C is equal to 19 sine 42. Divide each side by your 12.9. This is going to give you angle C. It's going to be found by taking the inverse sine of 19 sine 42 over 12.9. So use your calculator. And then since you're working with the angle measurement, you're going to round to the nearest whole number. So angle C is going to give you 80 degrees. Now the only thing left to do is to find angle B. So we found already side A, we have side B, side C, we have angle A, we found angle C, we find angle B by doing 180 minus the sum of angle A, which is 42, and angle C, which is 80. So this gives us that angle B is equal to 58 degrees. So if we write this all together with all of our side lengths, all of our angles, we have that angle A is 42 degrees, angle B is 58 degrees, angle C is 80 degrees, side A is 12.9, side B is 12, and side C is 19. For number 8, we're given that x is 5, y is 18, and z is 14. Treat this like A, B, and C. So we have our longest side length, which is B here. So we're going to use your B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. So this is just going to give us 18 squared is equal to 5 squared plus 14 squared minus 2 times 5 times 14 times cosine B. Your 18 squared is 324. Your 5 squared is 25. Your 14 squared is 196. Your 2 times 5 is 10, times 14 is 140, times cosine B. You are going to add your 25 and your 196 first. That's going to give you 324 is equal to 221 minus 140 cosine B. Move your 221 over by subtracting it from both sides. This is going to leave you with 103 is equal to negative 140 cosine B. From here, divide each side by that negative 140. And in order to find angle B, you're going to do the inverse cosine of 103 over negative 140. So the inverse cosine of 103 divided by negative 140 gives you 137.367. So we're rounding to the nearest whole number. That means that angle B is 137 degrees. You have just one angle. So you need to find your next two angles. To know which angle to find next, look at your side lengths. The second largest side length is side Z, or we're calling it C. So we're going to use sine B over B is equal to sine C over C. Plug your values in. This is going to give us sine 137 over 18 is equal to sine C over 14. Cross multiply. You have 18 sine C is equal to 14 sine 137. Divide each side by your 18. To find angle C, not sine C, we're going to do the inverse sine of 14 sine 137 over 18. So the inverse sine of 14 sine 137 over 18 is going to leave us with 32 degrees for angle C. So the last angle measurement that we need to find is angle A. And we can do that by just doing 180 minus the sum of angle B with the sum of angle C. So 32 plus 137, which gives us 11 degrees. So angle A is 11 degrees. So we put this all together, and we have that angle A is 11 degrees, angle B is 137 degrees, angle C is 32 degrees, and then side A, in this case, is X, which is 5, side B, in this case, which is Y, is 18, and side C, which we used as Z, was 14. We're going to move. So if we look at Heron's formula, remember your Heron's formula, you are using your area is equal to S, the square root of S times S minus A times S minus B times S minus C. And S is where you add up all of your side lengths divided by 2. So if we look at example 12, all three of these are using this formula, but if we look at example 12, we have that X is equal to 9, Y is equal to 11, Z is equal to 16, and they're all centimeters. We can use X as A, B as Y, and C as Z. It's the same exact thing. So to find your S, add up all of your side lengths, so 9 plus 11 plus 16, all divided by 2. So 9 plus 11 plus 16 gives us 36. 36 divided by 2 is 18. So S is equal to 18. Your area is going to be the square root of 18 times 18 minus 9 times 18 minus 11 times 18 minus 16. Plug it all into your calculator, hit your enter button. So the square root of 18 times 18 minus 9 times 18 minus 11 times 18 minus 16 gives you 47.62. It says to round to the nearest tenth, so that's 47.6 centimeters squared. Remember, if you're finding the area of something, your unit is squared. If we look at finding the area of a triangle when you're given two sides and an angle, you're going to use the formula A is equal to the two sides multiplied by one another times the sine of the angle that's given to you divided by 2. So if we look at 15, we're given that R is equal to 35 degrees, side S is 42 feet, and side T is 26 feet. So if we use our A is equal to side S times side T times the sine of angle R, all divided by 2, we're going to have area is equal to 42 times 26 times the sine of 35, all over 2. We are rounding to the nearest tenth here as well. So if we do this using our calculator, this gives us 313.172, so that's 313.2 feet squared. The next part from your review that you're gonna see on your test tomorrow, you have to know how to find your 6 trig functions. Given one of them, you have to find others. You also have to know your first quadrant is your two, like your X and your Y that are positive. Your second quadrant, so like this is quadrant 1. Your quadrant 2, your X is negative, your Y is positive. Quadrant 3, your both X and Y are negatives. And quadrant 4, your X is positive, your Y is negative. If, for example, we're given that the cotangent theta is -2 over 5. And they want us to find sine theta. If we are also told that sine is less than 0. Actually, no, sine is greater than 0. Let's do sine is greater than 0. Okay. We got to find sine theta. This is going to be similar to what you see tomorrow. This was also on your quiz. So, cotangent is x over y. So that means that x is either -2 or +2. Y is either -5 or +5. Tells you that sine is greater than 0. So that means y over r is greater than 0. So that y is positive because r is is always positive. So if the 5 is positive, that means that your 2 is going to be negative. You need to find r if you're finding sine. So use your x squared plus y squared is equal to r squared. That's going to give you -2 squared plus 5 squared is equal to r squared. So that's 4 plus 25 is equal to r squared. That gives you r squared is equal to 29. You take the square root of both sides, and you get that r is the square root of 29. So if you're finding sine, we said sine is y over r. So that's going to give us, where's r? 5 over the square root of 29. You cannot leave the square root of 29 in your denominator. So rationalize that denominator, multiply top and bottom by the square root of 29, and you get that sine is equal to 5 square root 29 over 29. Finally, the last thing that you could see on your test tomorrow is your linear speed. Remember, your linear speed comes from like one of those first sections that we worked on in Chapter 5. Your linear speed is found by using the formula LS, linear speed, is equal to your radius times your theta in radians divided by your time. For an example, it tells you given a clock with a second hand measuring 3.6 inches, how long would it take for the second hand to make a 3/4 revolution? Remember, your 3/4 revolutions here, we're going to be working with this one. So that means that 3/4 around your circle, 270 degrees. Your pi of that is 3 pi over 2. So you're going to use that 3 pi over 2 for your theta. It tells you that your radius is that second hand, so that's 3.6 inches. Then your time, how many minutes are around the entire clock, or seconds around the whole clock? It's 45. So we're going to plug this into our formula. So your linear speed is equal to your radius, which is 3.6, times your theta, which is 3 pi over 2, all over 45. You are writing this to the nearest hundredth, because you're dealing with seconds. So you can just plug this right into, plug this right into your calculator. And you're going to get 3.6 times, parentheses, 3 pi divided by 2, closure parentheses, all divided by 45 is 0.3769. So that's 0.38 inches per second. So you will have to know these revolutions here. So for a refresher, a fourth of a revolution is your theta is pi, because that's just 90 degrees. Your time is 30 seconds. No, that's half, sorry. Your fourth of a revolution is 90 degrees. That's pi over 2. That one's 15 seconds. Half of your revolution is half of 360, so that's 180. That's pi, and you're working with 30 seconds. 3/4, just what we just did. 270 degrees, so 3 pi over 2, and that's 45 seconds. And then a full rotation is 360 degrees, so that's 2 pi or 60 seconds. So once again, 8 questions. You're going to see your linear speed on there. You're going to have to find your 6 trig functions or use your 6 trig functions somehow. You need to know how to find or solve a whole triangle using your law of sines, solve a whole triangle using your law of cosines, finding the area of a triangle is going to be on there, and then finding an angle or a side length using your trig functions. So everything that we've gone over, you're going to see on your test.